Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. This is the second video of the third meeting. This is piping system with the turbine and the pump. What do you think if the pipe system will relate with the turbine? The turbine that spin in the water on because of the wind will mix the energy from kinetic energy to the electrical energy. But if we learn about the hydraulic and we learn about the piping system, so the energy is about the hydro energy. So the spin of the turbine will mix the energy hydro energy. In Indonesia, we can see in PLTA or pembangkit listrik tenaga air. Okay, stay tuned and we learn about the piping system with the turbine. This is the conservation equation. Do you remember it? It is about the continuity equation, the momentum equation, and the energy equation. And then don't forget about the pipe flow and open channel flow. In a piping system with a turbine, if you see that pembangkit listrik tenaga air or hydro energy, you will see the reservoir. The reservoir have the head of energy or energy head. And the cause of the energy, it's because of the potential energy. The potential of the water level in the reservoir. So the power of the energy or the power of the water flow is because of the potential energy. So from this, it is because of the water level in the reservoir will make the turbine spin with the highest velocity, and it will make the power. So from the power, it makes the electrical energy. Sometimes it's it's no need the reservoir. It will the energy also happen because of the potential energy on the river. It is micro hydro energy. It is because of the potential energy from the river, and then from this it has head of energy, and then from this it will mix the energy micro hydro. Now, because of the potential energy, we have head loss. We have head of energy. Because of the condition of the pipe that uh, will will make the turbine spin with the higher velocity or the highest velocity. So the water from the pipe will have the atmospheric pressure. So the energy or head of energy will lower, and makes zero in the atmospheric pressure. So it has energy losses. So the potential energy, it's not the total of the water level to the nozzle, but the head of energy is from the HS. HS is the the H equal HS minus HF, and H show the head of energy. It is from the static of the energy minus the head loss. Static energy show the total energy from the water level to the nozzle of the pipe. So HF using main formula, F times L over D times V squared over 2G. So you have this formula, and then you have H to show the head of the energy in the reservoir. So you can calculate the power using Q times H times gamma. Q is discharge and H is the energy, the head of energy, and then gamma is the specific weight. The specific weight of the water is 1000 kilogram force over meter cubic. Or in horsepower unit, you can add the 1 over 75. And if we have the turbine efficiency, so that the power is Q times H times gamma times efficiency over 75 in horsepower unit. And this is the second one in this chapter. It is the piping system with the pump. You know that the function of the pump is make the pressure head, so the energy will up from the lowest supplier. It is the pond or the pool that have the lowest elevation and have piping system which has a water flow to supply the water to the higher elevation. So it is the function of the pump. So the pump has a function to make the energy will up and up, and has the energy more than the demand pull, or the demand pull, like that. And the pump has two pipes. This is the suction pipe, and then this is the press pipe. The suction pipe will make the water level uh, will make the energy loss. It is HF1, and then after that the pump makes the energy will up until the energy uh, more than the elevation of the pool in B. Pool B, sorry. And then because of the head loss, and then it is HS. HS is the difference water level of pool A to pool B. And then because of the flow through the pipe 2, so it has HF2. So the total energy is because of the HF1, HF2, and also the static of the H, or the water level difference of pool A to pool B. So the H is equal HS plus the sigma HF. And the power of the pipe we can calculate using this formula, Q times H times gamma over the efficiency in the unit kilogram force meter over second. Or we can use the HP, or horsepower unit. You can add a 1/75 to find the power of the pump. This is the exercise. You can calculate the power of the turbine and the power of the pump using this data, and you can learn deeply by do the exercise. Okay, thank you. That's enough. That is the last material in third meeting. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.